Welcome to EDU World Space.
All right, so in this question, we have an arm that is holding up a carton of milk, and we're supposed to find the force that the bicep is acting on the forearm in order to keep the milk at the same height. So we're going to start with drawing a picture, as you might suspect, with these kinds of problems. So we have the upper part of the arm, which is vertical, and then we have the forearm, which is horizontal. So this is a right angle. Um, and then uh, at the end of the forearm, we have the milk, the weight of the milk. So we'll call that Fm. And then we also have the weight of the arm at its center of mass. So we'll put that up roughly in the middle, and we'll call that Fa. And then we also have the force provided by the bicep. So bicep is attached to the arm near the joint, but it goes all the way up to the top of the forearm. And it's at an angle. So put that there. And so we'll put the force provided by the bicep, FB, along this line. And then this is our point of rotation. The upper arm is 30 centimeters long, so we'll rewrite that in meters. So 0.3 meters. Then the tendon attaching the bicep to the forearm is 5 centimeters long, so we'll mark that length as 0.0500 meters. The length from the elbow to the center of mass for the forearm is 16.5 meters, so we'll rewrite that as 0.165 meters. And then the total length of the forearm is 35 centimeters, and we'll rewrite that as 0.350 meters. Okay, so then this system is in equilibrium. So we're going to be considering the fact that there is no net torque, no net force in horizontal or vertical directions. But first, let's label how strong our forces are. So we're finding the force that the bicep is exerting on the forearm. So we don't know that yet. So that is a question mark. But the force of the arm due to gravity is 18 newtons. And the weight of the milk, Fm, is 9.9 newtons. I'm going to rewrite that a little bit better. Okay, so like I said just a little bit ago, we're going to be looking at the fact that there is no net torque because we are in equilibrium, so T net torque net is equal to 0. We're not really concerned about the horizontal forces, so while the net force in the x direction is also equal to 0, and we can write that down, it's not really necessary to solve this problem. And then the other thing we're going to be looking at is that the net force in the y direction is equal to 0. So let's start with analyzing the different torques. So we have 3 different torques to work with here because all the forces applied to the arm are a little bit further along the lever arm distance away from the point of rotation. So we'll call the force provided by the bicep to be a positive force since the force is going upwards. And we'll call the torques created by the force due to the weight of the arm and the weight of the milk negative since those forces are pointing downwards. So the magnitude of the force, or the magnitude of the torque provided by the bicep, will be RB. We'll call that the length of the lever arm. For that, cross FB. And then the other 2 forces are negative. or the other two torques are considered negative because they're going in the opposite direction, so we'll have a minus sign here. And then we'll do the same for the force provided by the arm. So the lever arm towards the center of mass of the arm will be RA, and that's crossed with force provided by the weight of the arm. And then another negative, since our last torque is also negative. So this one is, we'll call the lever arm all the way out to where the weight of the milk is, RM, and that's crossed with the force of the milk. And then all of that is equal to 0. So with each of these forces, we want to look at the component that is perpendicular to the lever arm. So with the force due to the weight of the arm and due to the weight of the milk, they're pointing straight down, and the lever arm, the forearm itself, is horizontal. So they're already perpendicular to each other. So the magnitude of these two is just RAFA and RMFM. We do have to do a little bit more work with FB, or RB cross FB, since FB is at an angle. But if we look at the triangle that we have at the left there, we'll redraw it this way. This is our angle, theta. We don't know the length of the hypotenuse, but so FB is going along in this direction. But we do know that this bottom length is 5 centimeters, and that this side length is is 30 centimeters. So to find theta, we can do the inverse tangent of the opposite over the hypotenuse, or the opposite over the adjacent side. Sorry about that. In this case, that would be 30 over 5. Which, if you plug that into your calculator, you get that the angle is then 80.5 degrees. And then, if we look back at this triangle, FB is the hypotenuse here, so, and the forearm is going along the horizontal line down here, which means that the component of FB that is perpendicular is this vertical part here, which would be FB times sine of theta. So that is the component that we are concerned with, is FB sine theta, since that is the opposite side. Now, so let's rewrite our this equation here using the information that we just found. So we'll scroll down a little bit, get a little more extra page to work with. So RB cross FB is equal to RB FB times sine of theta. And then we said minus, and then we said that RA cross FA is equal to RA times FA, since the two vectors are already perpendicular. And same thing for RM and FM. All of that is equal to 0. So now we want to solve for FB because we're looking for the force provided by the bicep. So just do some algebra and we'll solve for FB. So let's move the RA-FA and the RM-FM to the other side of the equation first. So we'll have RB-FB sine theta is equal to RA-FA plus RM-FM. And then we just divide both sides by RB times sine of theta. So then we get FB is equal to RAFA plus RMFM. All of that divided by RB sine theta. All right, so we already know FA and FM just from the information we were given at the beginning of the problem. And then we can figure out RA, RM, and RB pretty easily by looking at our diagram. So those are the lengths of the lever arm. RB is going to be the distance from the elbow to where the bicep attaches to the forearm. So that'll be the 5 centimeters, 0.05 meters. RA is the distance from the elbow to the center of mass of the forearm. So that'll be the 0.0 or 0.165 meters. And then RM will be the distance from the elbow to where the milk is being supported, which is the entire length of the forearm. So that'll be the 0.35 meters. So then we have all the numbers that we need to solve this. We have our forces, we have our lever arms, and we know our angle. So we can just plug in all the numbers. FB is equal to RA, which is 0.165 times FA, which is 18 newtons. And that is added to RM, which is 0.350 times FM, which is 9.9 newtons. All of that is over RB, which is 5 centimeters, 0.05 times sine of theta. Theta is 80.5 degrees. You plug that into your calculator and you should get FB is equal to 130 newtons. There you go. That's how you do this problem.